Alright, we got another video. We're looking at Unit 12, Properties of Logarithms. And let's get started. Alright, essential question here is going to be what operations can be done to logarithms. Alright. The objective here, use properties to simplify logarithmic. Translate between logarithms and any base. So first looking at this thing, because logs are exponents, you can derive the properties of logarithms from the properties of exponents. All right. So, man, a lot of this goes back to when we did exponents. All right. If you had the same base, then you could add the exponents. Like if you had 2 cubed times 2 to the 5th. All right. Well, you could have 2 to the 8th because I can add 3 into 5 to get 2 to the 8th. All right. And so looking here at this rule, at these properties right here, the same thing applies. All right. Except right here with your A values. All right. So if I had log base 3 of 10 times 100, well, I can expand that. And they both have the same base. All right. But I can add log base 3 of 10 plus log base 3 of 100. All right, so here's the rule right here. All right, log base of m times n. All right, I can expand it to have log base b. Again, the base will be the same thing. All right, the base won't change. All right, but m plus n. All right, you can expand on it like that. Same thing with division here. All right, y'all see the rule over here to the right of your page. Oops. If you have the same base, all right, with m divided by n as the exponent, you can subtract it. Like if you had 2 to the 4th over 2 to the 1st, you can make that 2 to the 3rd. 4 minus 1 is 3. All right, and the same logic applies with dealing with this rule right here. All right, you have this base. All right, and you look at A in this division, you can subtract. All right, log base, and this would be M, this would be N. You can subtract like that. Keep the same base though. Do not change your base. All right, do not change your base. Right here again, this is multiplication. All right, this is multiplication. So first of all, I want to talk about this exponent. We did this last unit. When you have an exponent right here, it goes out front. All right, exponent goes out front. All right, like it did right here, 3 log, and then of 10. All right, 3 log, because when they expanded it right here, they went 1 log of 10 plus 1 log of 10 plus 1 log of 10. 1 plus 1 plus 1 is 3. 3 log of 10. Okay. So anyway, man, we're saying that, guys, this rule right here, and they explain it. The logarithm of a power is the product of the exponent and the logarithm of its base. So basically, guys, look, again, when you have an exponent, move it out front, okay? Move that exponent out front when A has an exponent. Because remember, we have log, all right, our base, then A. When A has a power, all right, move the power out front, all right, like so. All right, move the power out front. All right, use these rules, man. These rules are very straightforward. Last thing right here. Let me zoom out for this one. It says exponential and logarithm operations undo each other. All right, since they're inverse properties. Remember how the inverse of an exponent is a log and the inverse of a log is an exponent? Well, they undo each other. All right. So, like for example, if you have, see that example right there, like if I had log base 2 of 2 to the 4th, all right, well, the exponent and the base undo each other. All right, they undo each other, so the answer is 4. All right, so see how this example right here, log base 10 to 10, they undo each other. So the answer is 7. It equals 7. All right. On the contrary, all right, if you had a base raised to an exponent that was a log of the same base, well, again, the log undoes the exponent, right? You see that? They undo each other because the base is the same. All right. See that example right there? That 10 log of 10, base 10, they undo each other. The answer is 2. All right. So, man, use these sheets, man. Use this to refer to it. All right. Use that to refer to your rules when evaluating these problems. They're not hard at all. All right. So let's go and look through some examples. On this first sheet right here, it says, remember to change the base formula. All right. You can use this if you have A and B. You can divide it out. All right. Log of A divided by log of B. All right. So write the expression as a single log. So look, they got the same base. All right. Do they have the same base? Yes, they got the same base. So now look at our A values. All right. When I have the same base, and this is addition. All right. If I go back to the rule, I just want to refer back to the rule. All right, when it's addition, because right here we're condensing. All right, we're going to write as a single log, which means we're compressing it back into a single logarithm. All right, let me make sure y'all understand that. Right here we're condensing. This is expanded. We're going to condense it. All right, condense. All right, so to condense it, we make it into a single log. All right, specifically we're making it a single log with the same base. Okay, so when I do that, all right, back to the rule. Let me go back to the rule one more time just so you have a reference. Remember how you see right here we have log the same base, or m plus log base of n? Well, if I condense it, I'm going backwards this way. So it's just multiplication. All right, so it's going to be m times n. Keep the same base, it's just m times n. So again, I'm going to condense those so I keep the same base like we just said. All right, but we get 2 times 32. All right, which we can go ahead and condense to log base 4 of 64. All right. Now, we could actually solve this, but for right now, it just says write as a single log. So we're going to write as a single log, okay? This one right here, all right, is, well, here, I'm going to let you try 2. All right, this is addition, so you try that one. For this one, this is subtraction. All right, got the same base, but remember the rule for subtraction since we're condensing it. All right, C is log base B. Well, look, we got the same base. So log base B of M minus log base B of N. To condense it, you're going to do M divided by N like this. All right, M divided by N, but make sure you keep the same base. Notice the bases are the same. So we have log base 3 of 10 divided by 5. All right, and then we can reduce that. 10 divided by 5 is 2. So log base 3 of 2. All right, like that, okay? Just like that. Now, right here, this one requires a little work on your part. Actually, you know what? No. This one is just the power rule. All right, the power rule. And remember the power rule when you have this right here? All right, well, you can move that. Remember the rule is, see, let me show you how you use your rule. All right, move that out the way. Remember your power rule. You take your exponent, you just move it out front. Move your exponent out front. All right. So that's what we're going to do right here. See how they took P, moved it out front? All right, everything else stays the same. B of A. All right, log base B of A. So on our example right here, we're just going to move our 2 out front to have 2 log base 3 of 81. All right, that's our single log right there, okay? You try that one. Now, this one. All right, this one right here. There's a few things going on, but don't be discouraged, all right? Do not be discouraged at all. All right, we're going to write it as a single log. First of all, we have, and we just work from left to right since it's addition and subtraction. So we're going to do the subtraction first. So remember the subtraction rule. you took m and n and you divided them. So same base. So we're going to do log base b of 4x divided by 3y. All right. And then we still have plus log base b of y. All right. So now we use the division rule first because it says subtraction, right? So now this whole thing right here, this is my m. This is now my n. So now it's plus. So back to the addition rule. The addition rule told us that we take our two a's or our m and n, all right, and we multiply them because of the plus. So now we're going to multiply this times this, all right? So what you do is this. You get log base b of 4x divided by 3y times y because it's plus. All right. Now, if you remember your properties of multiplication, see those y's? This is y over 1, right? So I could actually cancel those out. So my final answer is going to be log base b of 4x over 3. Simple concept, man. All right. Don't if you struggle with that, just rewind it. All I did was do these two properties. All right, I did subtraction first, which means I divide this one and this one. And then because of the plus right here, I gotta multiply. Okay. I had to multiply. So just do it in order. All right. Now this one, we need to expand. Let me make this a little bigger. All right, expand. So first, I'm going to do, let's see, which part do I want to do first? Expand, okay, expand. We got to expand. Expand means make it bigger, right? Expand it out. So when we expand it out, the first thing we need to do is we need to separate the top from the bottom. All right, to separate the top from the bottom, notice is division, which means I end up with subtraction. All right, look at your rule. When it's division, you're going to get subtraction, okay? So, we go back to number 9. So we end up with, and remember, keep the same base the entire time. So log base of x cubed y minus log base 2 of z squared. Man, my z look like a 2. Good night. That's a terrible z, y'all. So I'm going to redo that. All right, minus log base 2 of z squared. There we go. It looks a little better. Now this side, we have the product rule right here. All right, where we're going to end up moving that 2 out front, right? But over here, see how this is multiplication, x cubed y? That's multiplication right there. All right, that's actually multiplication right there. So because these are multiplication, we can expand this one more time. All right, what I mean by that is we can go, it's multiplication, so we have addition. So you have log base 2, remember same base the whole time, x cubed plus log base 2 of y, right? Because that's multiplication. And then we still have this minus. Actually, you know what? Let's go ahead and do the product rule. Minus, remember that 2 is going to come out front. Minus 2 log base 2 of z. Like that. Now, we're almost done, but not quite. There's one more thing that needs to be done. See how we have the product rule right here? Well, the product rule, we see it one more time, and it's right there. See that 3? We need to move that 3 out front like that. All right, that's the last step. So what we finally get right here is 3 log base 2 of x plus log base 2 of y, almost running out of real estate, minus 2 log base 2 of z. And that is our final answer right there. All right, and it seems like a lot of steps because I'm just explaining everything. It's not. All right, once you practice and get good, like number 10, you'll go, oh, that's multiplication. I need this. I need to do addition right here. And then there's a power. So when I get this log, I move that 2 out front. And then right here is division. So I need to subtract that. And then there's a power. So move that out front. So minus 3 log base 4b. All right. So it just takes practice, man. You don't even need to do all that many steps, man. It's just because I'm thoroughly explaining that it seems like a lot. All right. Now, right here, number 11, it says evaluate without using the change of base formula. Well, again, see how, remember I told you how log and exponents are inverses of each other, they undo each other. So right here, log base 2 of 2, they undo each other. All right, they undo each other. So the answer is just going to be the exponent, which is remaining 3. Now, 8. 8's a little more, it involves a little more thinking. And here's what I mean. All right, 8 is 2 cubed. Think about it. 2 times 2 times 2 is 8, right? So I can make this similar to this problem right here. All right, you don't even know they're the same exact problem. All right, because 8 is 2 cubed. So I'm going to rewrite 8. All right, I'm going to rewrite 8 as 2 cubed. That's 8. Right? It's just substitution. So now, again, we got the same scenario to where the exponent undoes the log. So the answer is 3. All right. Now, going down here to number 25. Number 25, log base 5, 25 to the 4th. Well, ask yourself, can I undo this 25 to have the same base? I can. 25 is equal to 5 squared. So where this 25 is, I'm going to substitute log base 5. I'm going to substitute 5 squared, right, still to the 4th, because this is 5 squared, right? But it's still raised to the power of 4. So now if you look, right, remember the power to a power rule. You can multiply these. All right, so that's log base 5 of 5 to the 8th. 4 times 2 is 8. And then they undo each other. So the answer is 8. Now, right here. All right. Ooh, we got a base right here, but it's raised to a log. See how these undo each other? All right. Exponent undoes a log. All right. Go back and look at your rules, man. You ever get stuck? All right, look at your rules. See? See how you have a base raised to a logarithm, right? With the same base, they undo each other. So back to our example. Those undo each other. So that's 4. And then over here, remember we just looked at this. 5 squared equals 25. So we're going to rewrite that as log base 5 of 5 squared. Well, those undo each other as well. So now I just have, and that's 2. So you have 4 plus 2, which is 6. All right. 19. Evaluate using the change of base formula. Well, this one, guys, this is exactly what we did in Unit 11. All right. So the change of base formula is right here at the top of your page. All right, right there. Log base b of a equals log base 10 of a, which is divided by log base 10 of b. All right, and that's just log in your calculator. All right, so in your calculator, you just put, it's the same thing we did. Log of 15, log of a divided by log of b. Right? And when you do that in your calculator, 1.09. Okay. Now right here it says find the inverse. And this is just review, man, from everything we did on the last deal, man. Okay. So remember, step 1, swap x and y. Swap x and y. So x equals log base 4 of 3y. Now we need to rewrite this. All right, so you get 4 to the x equals 3y. and then you just solve it by dividing by 3 on both sides. So 4 to the x divided by 3 equals the inverse. There's your inverse right there. All right, I'm going to stop right here, man. We went a little longer than I wanted to, man, approaching 21 minutes. And, I really hope this helps. It's pretty straightforward. Watch the video. Bring me questions. We're going to practice, okay? And I will catch you later.